Hello Tachyons, this is Kumar and welcome to the TachyLab. We are doing force and motion, and in that we are doing movement and position, and I hope all of you have revised the graphs well, the last lesson, because that is the foundation. If you remember that, it'll be very easy for you guys to understand today's class. If you haven't watched that video, please do go and watch that video. Today we are going to study the graphs, but specifically the motion graphs. So in motion graphs, we have three kind of graphs here: distance time graph, velocity time graph, and the acceleration time graph. We'll be studying all three of them one by one. So starting with distance time graphs here. So in distance time graph, distance is going to be on the y-axis and time is going to be on the x-axis. So we see that if we have this graph, so with time, see the distance is same, it's not changing. So if I say that, okay, this is a path starting from 0, this is like 10 meter, this is 20 meter, this is 30 meter, and so on. And there is a person that stands on 20 meter. And after 5 minutes, it's again at the same point. At 10 minutes, again, it's at the same point. Time is passing by, but the position isn't changing. Then we say that, okay, the body is at rest because its position doesn't change with time. So this is how we draw the graph. So suppose if it is 5 seconds, this is the position, it will remain same 20 meter. Suppose this is 15 seconds and again it is same position. You can say it is 20 meter, it's not changing. We say that, okay, it is at rest, and with time, it's not changing. But suppose now with time, distance is changing. It is increasing. For example, at 0 second, you were at 0 meter. At 2 second, you are at 10 meter. At 4 second, you are at 20 meter. At 6 second, you are at 30 meter, and so on. So now if you draw the points, it will make a straight line graph here. So with the time, distance is increasing and it is increasing at a constant speed. So this is graph for constant speed, and in this case the acceleration is 0. Remember what was the acceleration? Acceleration was v minus u divided by time. So in this case the speed isn't changing, the speed is same. So u and v are same. So v minus u, let us say if it is 10 meter per second. So 10 minus 10 divided by any time, it will give you 0. So 0 acceleration graph. Then we look at the third one. So in third one, negative velocity. Now see, you can't get that in distance time graph because distance will always be positive, but rather it's a displacement time graph where you can have the negative distance. So in that, what happens? The position or the person might have returned back from 30, it came back to like 10 meters. So now it's decreasing, displacement is decreasing, right? So we get this. Now other kind of this distance time graphs. So you see now this is non-uniform speed. So the previous one, that was uniform speed where you got a straight line. But this is non-uniform speed where you're getting a curve. Whenever there is curve, it's non-uniform, right? If increase, speed is increasing, but now it's not increasing at a constant rate. So that means it is accelerating. And because distance is increasing much more in less time, that means there is positive acceleration. Same way it can decrease also. You can still be moving in the forward direction, but now with less speed. So that is negative acceleration. And lastly, again, it's a graph of uniform motion, but now the distance isn't starting from origin, rather it is starting from some point. It's like instead of starting from 0, you're starting from like 20 meters. Okay. Yeah, so distance time graph, we have already discussed this in the last class. We have two graphs here, A and B. So if I ask you which body is faster, so how would you interpret it? So if you look at A covered a certain distance which is higher in less time, while B covered a certain distance but in more time. And also looking at the graph, you can say that A is more steeper than B. That means the change that A has gone through is much more than B in less time period. So A has covered more distance. So A is moving faster than B. Now the graphs which are not at all possible. So if you look at this graph, so at that particular time, suppose in 1 second you just covered like 30 meters, it's not possible, right? Suppose now see in that particular time period, how can you be on two different locations? Again, not possible. Again, these graphs are not possible. Here the position is increasing and then decreasing. Not possible. Again, at the same time period, you see how the distance has increased enormously. Not possible. So again, it's not possible here. Now, slope of the, again, slope, the formula will remain same. Y2 minus Y1 divided by X2 minus X1. Here the quantity is time and distance. So it is X2 minus X1 is the distance. Like this is X1, this is X2, this is T2, and this is T1. And it will give you the speed. How do we calculate it? Because on x-axis it was distance covered and on y-axis it was time. So if we divide it, it is distance by time. And what is distance by time? It is speed. Now comes the velocity time graph. Now you might be asking then what about the area under distance time graph? So if you try calculating, it will be distance into time. Distance into time doesn't give you any quantity. So area under distance time graph as such doesn't represent anything. So you won't be asked that question in the exam. But for velocity time graph, both area and slope are important. Let's see how. First of all, let's read the velocity time graphs here. Again, you see that, okay, suppose 5 seconds, you have certain velocity. You are moving with like 10 meter per second. At 10 second also, again, you are moving with what speed? You are moving with 10 meter per second. So you are not rest here. You are moving with certain constant velocity. So you are in uniform motion. Uniform motion. I hope this is clear. Then next graph, you see how the velocity is increasing with time, right? It's increasing with time, but regularly. So this is positive acceleration. This is positive acceleration. So in this, the acceleration will also remain constant throughout. And if we have to talk about the example, let us say you have something and you just drop it. So gravity comes into play. So gravity 9.8 meter per second square. Acceleration due to gravity is one example of this. Then we have negative acceleration. So it is opposite of that. So if you just throw it in the air, what will happen? The velocity will keep on decreasing with time, right? So this is negative acceleration. Slowing down. Again, we have got the curves. Whenever curves come, that means it's non-uniform. So again, the velocity is increasing with time, right? It is accelerating, but now it's not accelerating uniformly, right? In the second one, again, velocity is increasing, but you see the curve, this curve here. Now it's not decreasing in regular manner. It is decreasing, non-uniform motion. Again, we have two curves here, A and B. So in this one, which of these bodies will have more acceleration? I'm not talking about who is faster. Which one of them have more acceleration? So you will look at the steepness. A is more steeper than the B one. And you know that in case of A has reached higher velocity in less time, while B reached a certain velocity in more time. And it might have reached the same velocity, but again, it would have taken much more time. So that means A has more acceleration than B. Again, there are certain graphs which are not possible. So at one time, how can you have like two velocities? Again, at that particular instant of time, how can you just increase your velocity so high? Not possible. And now comes the slope of the velocity time graph. How do you calculate that? See, slope is, you can say that, okay, this is V2, this is V1, this is T2, and this is T1. So it will be V2 minus V1 divided by T2 minus T1. So it is a kind of velocity, and this is time. Velocity time graph gives you what? Acceleration. So slope of velocity time graph gives you acceleration. Very important. Very important. Slope of velocity time graph gives you the acceleration of the body. Now comes area. So whatever shape it is, you find out the area. Okay, it can be rectangle, it can be triangle, it can be anything, it can be trapezium. But what you have to see, I told you that if you want to see the quantity, you simply have to multiply the x-axis and y-axis. If you have to find out that, okay, what is the like quantity, how much is it, then you find out the actual area. So if I have to say it is velocity into time, so velocity I can write as displacement by time. So time get cancelled and you are left with only displacement. That means area of velocity time graph gives you the displacement here. So if the question arrives, they give you the graph and they ask you what is the distance covered in speed time graph or what is the displacement covered in the velocity time graph, what you will have to do, you just have to find out the area under that graph and you will be able to get it. And yes, take care of the units. In this case, it will be meters. Okay, for area, it will be meter, and for gradient, it is acceleration. So let me do that also. So for velocity, it is meter per second. For time, it is second. So now the units will be meter per second square here. Take care of the units. Students usually do this mistake a lot. If you're liking my way of teaching and you are able to understand things better, do interact with the video in any way, like the video, comment, share it with your friends or subscribe to the channel. Yes, free notes are available and you can always find the link in the description box. For one-to-one and small group classes, you can contact us. Yes, now we have acceleration time graph. So this is a third and the last type of graph in the motions. So acceleration time graph, acceleration will be on the y-axis and time on the x-axis. So you see that how acceleration is constant throughout, it is not changing with time. Again, example, if you have something and you just drop it or you just throw it in the air. So basically when the body is under the effect of gravity, where it is 9.8 meter per second square, the acceleration, we say that, okay, it's constant. So body is moving in this case. Okay. Velocity is also increasing in this case or decreasing in this case. Then we have acceleration. So you see acceleration is increasing with time. It's not constant. So it is acceleration which is increasing. I hope this is clear. And these are two graphs, obviously decreasing acceleration and increasing acceleration. Both are examples of the non-uniform motion here. Again, area of acceleration time graph. Again, you have two things. You can find out the slope and you can find out the area. So area of the acceleration time graph, it is acceleration into time. How do we find it out? So acceleration into time, acceleration can be written as velocity by time. Time cancel and you get velocity. And units will be meter per second, obviously. So acceleration, area under acceleration time graph gives us change in velocity of the object. So if they ever give you this graph and they ask for change in velocity, just find the area under that graph. I hope this is clear to everybody. But now you will be like, okay, let us find out the slope. So slope is acceleration by time in that case. Acceleration by time doesn't give you anything here. So we don't need that. But I hope this lecture was useful to you and you were able to understand it. And now the questions, the graph questions will not bother you. Although we will be covering the graph questions in the next class. Do join for that video and learn and share this video and do let me know in the comment section if you're actually liking the series. Thank you so much. I'll see you in the next class.